Good afternoon, everybody. We're running a little late, having a few technical problems. I'm Normie Buehring from Mississippi State, and today I want to talk about long-term crop and residue management and conservation tillage systems with various tillage systems. We're appreciative of Soybean Promotion Board, Mississippi Soybean Promotion Board, USB, and Mississippi Corn Promotion Board supporting this project. Our objectives here, as you can see, were to look at determining corn and soybean residue management and tillage systems influence on soil quality, soil aggregate stability, water holding capacity, respiration, and soil microbiology, biomass, and the crop yield, and what the economic returns are. Just want to point out that this is all the wheel tracks ran between the rows. These are on 38-inch rows that in non-irrigated environment, and the irrigated environment was in 40-inch rows. Soybeans were 38-inch rows and non-irrigated, and 40s with twin row beans on the irrigated environment. Our locations were non-irrigated at Verona, northeast Mississippi, and the other one was Stoneville in the irrigated environment. Our soil types were Marietta loam at Verona, Stoneville was a bosket, dove, silt loam. Our crop residue management consisted of burning the corn crop residue and not burning the corn crop residue. We didn't burn the soybean residue since there's such a small amount left when you harvest. Our tillage system we called reduced till. This was we knew with corn we needed a bed on these flat grounds to grow a good crop of corn, so we tried to see if we could go, how many years we could go without reshaping those beds. In most cases in the dryland system, we were able to go about every other year after the first 3 years. At Stoneville, due to the excessive rainfall and 16 and 15, 16, and 17, we had to redo those beds in the spring of the year. Usually when they got below that 3-inch, that was our key that we tried to use as a guide. We used a bed roller system, Terra-Till, which is an in-row subsoiler, one-pass operation. The disc that was provided to us by Big Mag out of Lubbock, Texas. The treatments, we had also a treatment we called, I guess, our conventional, was disking twice and followed by in-row subsoiler. Well, where's Tom at? This technology is far beyond me. Okay, this was our Terra-Till, and you can see it was a bent shank, offset shank. We had coulters on the front of it running in front of that subsoiler. We also had a coulter running in front of our bedder, and we had shields on our busters and the rollers behind it. The bed roller, just an example here, we also had the shields. It helped us to clean out the furrow, so better drainage is what the use of those yellow shields. Okay, the spring ground residue cover that we did on a foot basis, just pulling a tape diagonally across those plots and counting it, whether it was corn crop residue, old residue, or whether it was green vegetation, winter vegetation. And basically what I want to point out, this is at Stoneville, but also at Verona, is that the reduced till in all the cases had all across those years had significantly higher ground residue cover is what you expected. Less tillage, more ground residue cover. The ground residue just protects that soil from erosion potential. But the other thing interesting, the Terra-Till, the in-row subsoiler, was the next best in terms of ground residue cover. And this system, due to that bed shank, it lifts it up, and the bed roller does not cover the top of that bed as much. Okay, the crop residue management where we're showing the burn and no burn. This is averaged over 6 years. The reduced till, if you look, the bed roller had the significantly higher beds, which is what you expect all of those years, across all those years. And the nut where we did not burn was statistically significant, with slightly taller beds. And again, you had a residue on that surface bed that helped prevent it from eroding. And you can see that in all cases, the disc plus tear till always had the lowest bed height in the spring of the year. We did that usually in March when we measured those highs. All right, crop residue management effects. In Stoneville, an irrigated environment, we didn't see any effects, but at Verona, non-irrigated, these were the years that we've seen effects, differences between burn and no burn. This is an average across all tillage systems. And you can see not burning, we had higher ground in 2014 and 2016. That was the only significant where burning had an influence. And also the soybean yield in 2013, where we did not burn the crop residue. Previous years, corn crop residue, you see we got a significant higher yield. That was the only year. In corn, these are rotated, soybeans and corn every other year, swapping back and forth. We did see an effect where it had significantly higher yield. If we look at what residue had in effect, there was an interaction across the burn and no burn with these reduced tillage systems, and you can see that in all cases, the most significant thing is that where the disc operated, we did get a significantly higher yield with the no burn. But I like to point where the tear till, it didn't make any difference, but it was as good as where the disc incorporated. So that was the interesting thing that we've seen happen there. We look at the average corn yield across those 6 years, we didn't see any interaction with tillage. We did see a year across year some effects, but was not statistically significant every year. But I want to point out corn yield in a non-irrigated, the tear till at the highest was higher than the other tillage treatments. At Stoneville, tear till, bed roller, and the disc plus tear till were not significantly different. It was greater than the reduced till. If we look at the soybean yield at Verona non-irrigated, we had significantly higher yield than the other three treatments. And if we look at Stoneville, there wasn't any difference, reduced till. That just shows that soybeans are not quite as sensitive to me as I interpret the data for bed height as corn is. And so we didn't see that in the irrigated. We did pick up that in a non-irrigated environment though. Okay, if we look at the returns, this is the returns above tillage costs. It's total specified tillage cost, the cost of the equipment, and the fixed and direct expenses. And if you see at Verona in soybean, these are soybean returns. This was not different from the bed roller, but it had numerically higher returns with the tear till than the other treatments. At Stoneville, you can see reduced till there wasn't any statistical difference, but the reduced till, the trend was for higher yield, slightly higher returns, not yield, returns, than the other treatments. If we're looking at the corn returns, you can see there wasn't any difference between the tear till statistic-wise and bed roller and the disc plus tear till. They were different and higher than the reduced till. But numerically, the tear till had a higher return than the other treatments. If we look at Stoneville, there was the corn bed roller and the tear till gave us numerically higher, but it wasn't different from the disc plus the tear till, but they were numerically greater than the reduced till. Looking at soil quality results, Verona didn't have Stoneville's yet, but this was 2017 year. We started out at Verona, soil organic matter for the whole study was 0.84. And you can see in 2017, the reduced till, the bed roller, and the tear till had significantly a greater organic matter than the disc plus the terra-till. We look at the factors on soil quality, soil aggregate stability, water holding capacity, the microbial biomass, and the soil respiration. You can see in all cases at both locations the reduced till had significantly higher numerical values than the other treatments both years. Then if we look, the next best was terra-till, not every year in every case, but it was some cases was not different than the reduced till. Some years it was. One thing I learned out of this study, you got soils, they're not the same. When you pull the samples out of the field, you still, that's just for that sample. That's about it. But you see some variability from year to year. But a reduced till in all cases, in both locations, irrigated, non-irrigated, was, in other words, saying less tillage is better for soil quality and soil health. Okay, to kind of summarize the results, in both the irrigated and non-irrigated environment, the disc operations did not enhance yield or net returns, and it had a negative effect on the soil quality factors. One thing, there was some work funded by USB, had a soil microbiologist postdoc work on this and looking at organic. And what he found was that proteobacteria identified this bacteria that's found in the soil, which destroys the organic matter, was greater quantity in the disc situation, had that more than the other tillage systems. From a crop residue management standpoint, it wasn't what we expected. We'd expected to see greater influence, but we saw at Verona in the non-irrigated environment, in both cases, all locations, we had less ground cover and lower bed height. We've seen that at all locations, but at Verona on yield, 2013 for soybeans and corn were greater where we did not burn the crop residue. One other thing, when you burn the crop residue, you destroy the nitrogen goes into the atmosphere and also the sulfur, so you're denying your soil bacteria what's necessary for them to function. In the non-irrigated environment, the terra-till yield and net returns was greater for both corn and soybeans. And if we look at the irrigated environment for corn and soybeans, there wasn't any yield or net returns differences between those tillage systems. Some slight, in reduced till as an example, was slightly numerically better than, and the bed roller was better for corn. The soybeans reduced till was a good. In the irrigated environment, we did run a furrow plow through those so we could water. We furrow irrigated, and we based that on rainfall and environment and that type of thing. And one thing I don't have on it, probably in the irrigated environment, another look needs to be taken at looking at the terra-till in-row subsoil with soil moisture sensors to better determine. Maybe you could skip an irrigation with using the in-row subsoil. We didn't look at that in this because we didn't have soil moisture sensors. Selected conservation tillage systems such as a terra-till can improve yield and net returns, particularly in a non-irrigated environment, and enhance soil quality when you compare it to the disc. Economic and yield results, what was interesting, for non-irrigated and irrigated environments were the same as reported by Pringle for cotton at the Delta Station, where he showed that the same results had higher yield and higher returns in the non-irrigated were in-row subsoil, and in the irrigated environment there wasn't any yield or return differences. I'll take any questions, or we can move into our grower I have here today is Keith Morton, a friend of mine in North Mississippi. He's a grower, and I'll turn it over to Keith, and we can take questions at the end if we got time. Thank you.